Hi, and welcome back. So let's just keep doing a couple more examples of these electronic and molecular geometry examples. So remember, we're going to be trying to find the electronic geometry, the molecular geometry, the ideal bond angle, and what we can expect for the actual bond angle of these molecules that we're looking at. So in this example, we're going to take a look at the molecule for CHCl3. So now let's just go ahead and we're first going to find each of these on the periodic table. So we've got our hydrogen, which is going to be our first element, which is up here. We have got our carbon, which maybe you can't see that color on the white periodic table, but our carbon is right there, and it's going to have 4 valence electrons. And let me just say our hydrogen is going to have 1 valence electron. And then our chlorine is going to be right here. It's a halogen on the periodic table, and it's going to have 7 valence electrons. So now, what do you think the central atom is going to be? Well, it's going to be carbon, right? We're able to bond 4 things onto our carbon, so carbon is going to go in the center. And let's just go ahead and draw the structure. So we could draw one of the possible resonance structures that we could draw for this would be carbon bonded to a hydrogen, and then bonded with a chlorine, which is going to have 7 valence electrons plus, or it's going to have 7 electrons around it. And then what is our structure going to look like? We're going to have 4 things bonded onto this carbon, so we can actually just start drawing our structure. And hopefully you can already see that the structure is going to be tetrahedral, right? Because we've got 4 different atoms bonded onto our carbon. And carbon has 4 valence electrons, so we're not going to have any lone pairs on our carbon. So let me actually just start drawing our tetrahedral structure. So I'm going to draw my wedge. So there's my wedge that's supposed to be popping out of the computer screen. And that's going to be a chlorine. And then I'm going to switch colors, another chlorine that's going to be going back into the computer screen. And again, it's going to have 3 lone pairs around it. So this is going to be our structure, and I guess I already gave away what the geometry is. Let's start out. What's the electronic geometry? What's the electronic geometry? Well, we've got 4 different electron groups around our carbon. So for 4 different electron groups, our electronic geometry is going to be tetrahedral, right? And then what's our molecular geometry going to be? Molecular geometry. Well, we've got 4 electron groups, none of which are lone pairs. They're all bonding. They're all bonds around our central atom. So therefore, our molecular geometry is also going to be tetrahedral. And then finally, what is the angle? And I think in all of these final prep examples so far, this has been the same angle, but what's going to be the angle, the ideal bond angle between these bonds? Well, it's going to be 109.5 degrees, right? That's the angle that's the ideal angle for a tetrahedral structure. So this angle is going to be 109.5 degrees. And then the final question, can we expect any deviation from this 109.5 degrees? And no, we shouldn't expect any deviation because none of our electron groups around our central atom are lone pairs. They're all bonds, so they're all going to repel each other with an equal amount of force. So we're not going to expect to see any deviation. So deviation should say, no, we're not expecting any deviation. And the actual bond angle we are going to expect to be 109.5 degrees, same as our ideal bond angle. So anyway, hopefully you found that useful, and I'll just keep doing examples. So I'll see you in a future video.